Okay, now we want to talk about what heat is. Now we're going to abbreviate the word heat with the letter Q, a lowercase letter q, and then it is going to have the units of energy, which is joules. Now, heat is when you transfer energy from one place to another due to the random motion of molecules. Okay, so what I mean is, let's pretend first that we have a solid, and in a solid it's going to be composed of atoms, and I'm just going to say that these atoms are in a lattice that kind of looks like this, and then the atoms are feeling electrostatic forces from each of the other atoms, and we can symbolize that with springs. Now, there's not really going to be springs that are going to be holding these atoms together, but we can think of this as springs because we know that if you have two positive charges and you try to push them together, they're going to repel each other. And then also, if we have two negative charges, they are going to repel if you try to push them together. And if you have opposite charges, they're going to attract. So for each of these atoms, so let's draw a larger view of this. So each of these atoms is going to have a positive nucleus, and then it's going to have a negative electron in orbit around it. And so similarly on this one, a positive nucleus and then negative electrons in orbit. So if you try to push them together, these two negative charges are going to be seeing each other, and they're not going to like each other, and they're going to repel. So that means that if you try to push these things together, they're going to repel. But on the other hand, this negative one over here sees this positive, and it's being attracted to it. So that means that if you try to pull the atoms far apart from each other, they're going to be attracted to each other because of the opposite charges. So it's a constant battle between the positive and the negative charges. And so this is really the way a spring operates. If you take a spring and you push it together, it wants to push it apart. If you take a spring and you pull it apart, it wants to come back together. So that's why we can represent the electrostatic attractions between each of these atoms as being springs. Okay, now what we're going to do is we're going to transfer energy to this thing here. Now, we could do it in a multitude of different ways, but let's say that we have like a candle. And so here is our candle down here, and we're going to apply energy to this solid. Well, what it's going to do is it's going to make these atoms start to move, but they're going to be moving in completely random directions. So maybe this atom is going to start to vibrate like this, and then this one is going to start to vibrate like this, and then maybe this one over here is going to start to vibrate like this. So you notice it's random vibrations. And as these things are vibrating, what's going to happen is it's going to cause these up above them to also start to move. So as these are moving, it's going to cause these to start to move, and then as these are moving, it's going to cause the ones above them to start to move. So notice that we are transferring energy from the candle into the solid, and then it's making all of these random motions. Now, in the case of a fluid, so a fluid can either be a gas or a liquid, it's a different story, because in a gas, you have these gas molecules, or it could be a liquid, and so you have these liquid molecules, and now they are free to move anywhere that they want. So they're not tied together by these electrostatic forces. So that means that this one could go in this direction, and then this one can go in this direction. But the more energy that you add to the system, the more energy the individual little atoms are going to have, and they're going to start to be moving randomly. So that's what heat is going to be. It's the transfer of energy from one place to another. And then what it does, though, is heat will cause atoms to move around randomly. The faster that they're moving, the more heat is being added to the system. All right, so now we're going to take a break. And when we come back, we're going to talk about then what is temperature.